Okay, good evening, everyone, and welcome to today's class. Today is the second Python live class. Okay, and it's basically a continuation of what we did last time. Okay, so here's a quick overview of what we're going to be doing today. We are going to be looking at what variables are in Python. We are going to be looking at how to manipulate variables. Okay, I'm also going to be looking at loops and branches, which will be like while loops, if and elif else. Okay. And we're also going to look at how to create simple Python programs. Okay. So we will create like a word count program, which is a program that counts the number of words in a sentence or in a text. And we're also going to see how to create a simple calculator, okay, that works on the command line. So there will be no GUI for that. Yeah. Okay, so what are variables in Python? Okay, so Python variables serve as a reference to objects in memory. Okay, so they serve as pointers to specific objects. So in Python, everything is an object, okay? Everything exists as an object in memory. So that's how the C Python interpreter maps objects from memory addresses to actual objects that we can interact with from our IDLE. Again, so variables allow us to reference these objects. So I'm going to do a very quick demo with my IDLE. Okay, so I'm going to run my IDLE. Yeah, so I'm running Python 3.10. Okay, and I just ran that from my terminal. Okay, so quick check, I can print hello world. Yeah. Okay, so an example of a variable would be assigning the object 10 to the variable A. Okay, so in this case, A is the variable and 10 is the object. Okay, so if we were to perhaps print the value of A, we would the Python interpreter would go to the variable A and get the object that it's referencing, which is 10. Okay, so we could go ahead and maybe say B is equal to A. Okay, and we print B. Okay, and we're going to get the same value basically because B is pointing to the same value as A, is pointing to the same object rather. And something interesting, if we should be able to change B and then, yeah, so because we changed the object B is being assigned to, it no longer references the same object as A. Okay, so for example here, we said B is now equal to 11. So this is an assignment operation. We make use of equal sign to assign objects in Python. So we assign the object 11 to the variable B. Okay, and so now B is no longer equal to A. We can check that by doing A is B, which should return false. Okay, so in Python, we have mutable data types and immutable data types. That's a bit of a more complex topic, okay, but the whole idea is that we can modify some values without changing their object reference or their memory address, or we cannot do that for other objects, okay? So for example, we have a list, okay, and our list is, let's use C this time, okay, and C is equal to 1, 2, 3, okay? And so we can just see the value of C, which is 1, 2, 3, okay? And then we have, let's say D is equal to C. Okay, so one thing to note here that lists are mutable basically. So that means that we can modify a list without changing its memory address or the object that it references. So what does that mean? That means that we can go ahead and say D, the first element of D, which is D0, okay, D index 0, should equal to per se 200, okay, and D is still going to be the same as C. Again, if we print out C, we should get 200 as the first object, 2 second object, and 3 as the third object or second index. Okay, so that's very important to notice is that some data types are mutable while others are immutable. Okay, so it's just something that sometimes shows weird bugs in your program. Yeah. So just know that lists, floats, integers, strings are immutable, while lists and dictionaries are mutable. Okay, so we can change mutable objects without changing the memory address or creating a new object. So Python is actually doing a lot behind the scenes when we assign variables. It's creating a new object and then assigning a reference to that object to the variable that we named. Okay, and Python does not support undefined variables basically. So if we have a variable, say, um, yeah, my number, okay, and we're using snake case because this is Python, okay, and then we don't assign it any value. we're going to get an error that my number is not defined. Okay, so every time you create a new variable and that variable has not been assigned before, you have to assign it a value because Python does not know what it is. It's a dynamic language. Yeah. So there's no ability to define undefined values in Python or undefined variables. You have to give a variable a value the first time you define it. Okay. Yeah. So we're going to go straight to what are operations. Okay. So first thing to know is what are operators, because it's with operators that we build operations. Okay. So operators are basically arithmetic symbols, okay, that we use to perform functions or calculations between variables, basically, or between data types. Okay. An example of that would be plus. Okay. So we can use plus to add to numbers or floats. Okay. So we have 2 plus 5, 7. Very straight to the point. We could also have 5.6 plus 2.5, okay, and that gives us the correct answer of 8.1. Okay. But then it also works with strings as well. Okay, so we could have a string of maybe good, okay, and we add morning there, okay, and that should give you good morning. Okay, so we have good morning. So basically when we use the plus sign operator with different data types, we get different operations. With integers or with floats, we get addition. Okay, and with strings, we get concatenation, which is similar to addition, but on a string level, basically. So we add the strings together. Okay, and it also works with lists. So for example, we have 2, 3, which is a list, and we have another list of maybe 7 and 8. Again, we can add them together and we get a bigger list, okay, that contains all the elements. Okay, okay, so basically this is addition with list. Okay, yeah, so this is what the addition operator does with list. Okay, and then we could also use this with it. Dictionaries don't really support the addition operator. Okay, so we could try this out. Again, I would get that this is not supported because dictionaries are a particular and peculiar type of data type in Python. Okay, so they usually used as hash tables. So dictionaries are Python's implementation of a hash table. What that basically means is that you usually use it to store references to values. Okay, so to store like custom keys to a custom index. Okay, or custom key to a custom value rather. Okay, so index a dictionary, for example, could hold people's names. Okay, example, people's names. We could have Joe got 10, and maybe Ben got 20 as a score. Okay, so dictionaries are used to map keys to values, basically. So this is an example of a dictionary. Yeah. Okay, so that's operations. We also have lots more operators. We have the minus sign. Okay, so we could use that with normal numbers. For example, 45 minus 10. Okay, so this is the subtraction, basically. In this case, it plays the part of subtraction. Okay, and string shouldn't support this. Okay, string shouldn't support subtraction, this operator. So we're going to get an undefined because basically Python does not know what we want it to do. Does it mean to remove O from 2? Python does not understand English, so obviously it throws an error that it does not understand what we wanted to do. So per se, we wanted to remove the value O from the variable 2, from the string 2 rather. You could assign this to a variable. Let's say the number 2 is equal to string 2. Okay, and let's say we want to remove the O. Okay, to remove the O from number 2, we could basically index that. Okay, and we could get the first two values, which is 1, 0, and 1. Okay, so 0 till 2. Okay, and so we basically, this is indexing. Okay, we're indexing a string. So we specify the first value that we want to get, which is 2, which is the first value, which is 0. So counting or indexing starts from 0. in Python, okay? And then we specify the last index that we do not want to add, okay? So that's the third element or the second index, okay? So Python is going to return all the elements in between this range, which is this first, which is the 0 index, and the second, which is the first one index, okay? Which is TW. So this is how we might remove a letter from a string, okay? And we still have the multiplication operator. Okay, that's basically multiplying two numbers. We could do the same um, floats as well work. Okay, and we could also do something pretty cool with strings. Okay, so let's say you have a string of hello, okay, and we could actually multiply this by 5, and what Python is going to do is going to return this string 5 in 5 places basically. So you could maybe add space between these, okay, and Python is going to basically add a space between each of these strings, okay? So that's multiplication between a string and an integer, okay? But multiplication between strings and strings doesn't work. Python is going to throw an error, okay? You can't multiply a subsequence by a non-integer, okay? So basically that means that multiplication by a non-integer is not supported by strings, okay? So let's also support multiplication. What it just does is similar to what happens with strings, okay? So we're going to get multiplication. Yeah, that's in 15 places. So the list basically grows to 15 places. Okay, so we could have that in 2 places. Yeah, dictionaries do not support that. Yeah, okay, because that the computer would not understand how to handle that basically, because dictionaries must always have unique keys. Okay, so that's operations. We've handled a bit of expressions. So expressions are basically when we combine operations together, okay, to create maybe a value, a variable, okay. So for example, um, yeah, let's say we have a variable a is equal to 10, b is equal to 5. Okay, and we have a plus b. This is an example of an expression. Okay, we could have a times 5, a times b. Another example of an expression. Okay. Then we talk about assignments. So assignments are basically when we yeah. Okay, so assignments are basically when we assign a value to a variable. Okay, so we basically reference create a link to that object reference in the ideally and assign that to a variable. Example would be a is equal to 50. So this is an assignment. So we're assigning the object 50 to the variable a. Okay, we could also have any other variable really. My name or name rather is equal to Joe. Okay, standard. Okay, so we assign the string to the variable name, to the variable name. Okay, so there's a variable called name now, and we can actually just print its value. Okay, so somebody might ask what have you tried son name? Okay, but Python doesn't know anything about the variable son name because we have not defined that yet, so it's going to obviously throw an error. Okay, and just to notice now, there are a couple of reserved words, okay, or keywords that we cannot use as variable names. Okay, so example would be import or print. Okay, for example, so we cannot use the variable name print is equal to 20. We should get an error. Okay, so that allowed us to work. Okay, for example, we could not use the name 4. 4 is equal to 20. That's reserved. So 4 is a reserved keyword. We can actually get the list of all keywords with this simple expression, keywords rather. Okay, so all the reserved keywords, which we cannot use as variable names, are listed out here. So that's false, none, true, and, as, assert, async, await, break, class, continue, def, delete, etc. Okay. Yeah. So for example, we could not create a variable called lambda. That would throw an error. Okay. We're obviously going to uncover what all these keywords are used for later during this course. Okay. But for now, it's just good to know that we can't use them as variable names. Okay, I think that sorts that out for variables. Yeah. So on to loops and branches. Okay, and because we're working with a bit larger piece of code, okay, I'm going to be making use of a text editor to write the rest of this code. Okay, so I'm going to create a new Python script. I have VS Code open already. I'm going to come over to the Explorer, File Explorer. I'm going to create a new file. Okay. I think we're going to call this loops and branches. Okay, .py, that's the extension of every Python file. I'm going to increase the screen size, yeah, so you guys can see that better. Okay, so what are loops and what are branches? Okay, so let's start from that. Okay, so loops are basically continuations. Okay, they are continuous bodies of logic that repeat until we tell them to stop repeating, basically. Okay, and then branches are pieces of logic that do not execute. um Okay, so only one branch can ever execute usually in a Python script. Okay, so if we have like an if-else block, only one of those will execute. So that's the whole idea of branches. So we can branch our code or our logic basically to take two different parts depending on whatever condition we choose. So that's the whole idea of loops and branches. Okay, so let's start from branches. We're going to make use of the if. Okay, if branch. Okay, so if basically check whether condition is true. Example would be if 10 is less than 20, print 10 is less than 20. Again, and we can just run this straight from VS Code. I have a couple of extensions installed, so I just get this pop-up right here. Okay, or we could actually use run without debugging, whichever you prefer. Again, that's supposed to launch a process. Yeah, so that's going to launch a new Python process and basically try to run our script. Yeah, so that's our startup time. And yeah, we get an output 10 is less than 20. Okay, but you could also install an extension because that makes it really easy to just start a new Python process and run your script straight from there. Yeah. So if we try that with this extension, which is the official Microsoft extension for Python, yeah, we should get the same output, which is 10 is less than 20. Okay, but then this sort of clutters our terminal. Okay. And so I like to actually run my script from a separate terminal, separate process. Okay. So I have Windows Terminal open, and in Windows Terminal, I have Windows PowerShell open. I'm just going to create a new PowerShell instance. Yeah, I'm going to cd into directory. Awesome. And I'm going to run the file. So loops and branches. We get the same output, but this looks a whole lot nicer to me. So we're going to be using this to run our code henceforth. Okay, and then we could also try another condition. Okay, so if 5 is 5 is equal to 20, which is obviously false, we should print 5 is equal to 20. And we run that and we only get a single bit of output. Okay, because the other branch did not execute. So this is what I mean by branching basically. So only this branch will only execute if this condition is met. So that's what the branch means. Okay. Yeah. And so we can also explore the next type of branch, which is an elif branch. Okay. So elif stands for else if. Okay, which stands for else if. So if you're familiar with other programming languages, that's the same paradigm, basically else if run that. Okay, so we make use of that with always a preceding if block. So elifs are always chained to a preceding if block. Okay, and so example would be if a is equal to b. So you can also make comparisons over strings. Okay, we're going to print a is the same as b. Else if elif a is not equal to b, you can say print A is not equal to B. Again, we can go ahead and run that. Okay, and we're going to obviously get the right output, which is that A is not equal to B. So what happens is that the Python interpreter is going to try to run this, check whether A is equal to B. Obviously, you're going to get false, so it's not going to execute this. So it's going to come to the next elif branch, which is chained to the first if branch, and it's going to check that the condition actually fires, and it's going to print out A is not equal to B. Okay. So very interesting. Now we're going to see a very interesting property of elif, which is that only one branch of execution can actually execute. What that means is basically if this fires, any following or subsequent elif branches are not going to fire. Example, we have 100 is less than 200, which is obviously true. Okay, but then if we run this, we're only going to get A is not equal to B. Why? Because only one branch of logic in elif tags can ever execute. That's the whole idea of elifs. Okay, so they're chained and then they never execute subsequent branches. So only one branch of logic can ever execute in an elif situation. So why would we make use of elifs? Elifs are really useful when we want only one possible output. So per se, a user is trying multiple times to per se maybe log in, okay, and we want to restrict that to, if they try like 10 times, they should be restricted. Else, if they try to reset their password, we should take them back, okay? And we only want one branch of that logic to ever execute. So LF will really come useful there. Okay, and one very useful property to note is the else branches. Okay, so else branches work by catching all other conditions. Okay, so peradventure we have if 500 is not equal to 1000, which is obviously false, print 500 is not equal to 1000. Okay, so this is going to evaluate as true. Again, we can add an else block right here. Okay, so else does not take any condition. That's very important to note. If blocks take conditions, elif blocks should take conditions, but else blocks do not take conditions. Okay, and we can basically just tell this to print 500 is equal to 1000. Okay, and so we don't expect this block to ever run. So we can actually go ahead and try that out. Okay, so 500 is not equal to 1000 printed by the if block. Okay, but per se we wanted to check that. Okay, if 500 is equal to that 1000, okay, and we can say 500 is equal to 1000 here, which is already false. We'll go down and say elif 80 is 880 or 80 is greater than 90. Print 80 is greater than 90. Okay, else print 500 is, oh, we can just say else print running the else block. Okay, and we go ahead and run that. And we see running the else block. What that means is that none of these conditions were ever met, and so else is going to run. So that's the whole idea of branches. Okay. Yeah. Important thing to note is that we're basically working with booleans. Okay. So we could have caged this value of per se 500 is equal to 1000. Okay, in a boolean. Okay, so our flag, we could call our flag, which is equal to this. 500 is equals to 1000 is a condition. So this is going to be a boolean, which is obviously false. So our flag is equal to false. Okay, and this should, you can just replace this with our flag, which is a boolean. Print 500 is equal to 1000. Okay, and then we can put an elif here just to make things really clear. Elif false. Okay, print 800 is greater than 90, else print this block out. Okay, and then we could also have another one just to show how true looks. So same thing with true. Print running true block. Yeah, and we can actually go ahead and run that. running true block, because that executes. Okay, another branch executes. That's how Python works. Okay, and important to note is that VS Code just grayed out these areas for me to show that they will never execute. Okay, so VS Code is smart enough to notice that. Yeah. On to while loops. Okay, so I'm going to go ahead and just create a new file because I feel this one's a bit bunched up or taken up. Yeah. So loops dot py. I want to rename that. Okay. If I dot py and just delete that. Yeah. Again, let's take a look at what while loops are. Okay, so while loops basically keep executing till so basically we tell them to stop. So while loops are going to keep us in a loop, a literal loop until we tell them to stop. So for example, maybe you want it to keep waiting, okay, until it's sunrise before you go to school or you go to church or you wake up, okay? And what you're going to do basically, you're going to keep yourself in a while loop. You're going to stay on your bed and you're going to keep checking whether the sun has risen, okay? And if it has, you're going to stand up and start your work or your daily activities or whatever. So basically, that's a while loop. So we keep checking the condition each iteration, okay? And if that condition is true, we remain in bed. What that means is that if that condition, which is that the sun has not risen, we remain in bed, else we break that loop, okay, and we start our day. So that's the basic while loop. So we can actually code that out, okay, just a literal representation of that. So let's say it's a new day, which is actually false. Okay, so that means it's nighttime. Okay, so I think that's a better name. Nighttime. Is nighttime. It's false. Okay, so that's a far better variable name. Is nighttime. It's true rather. Okay. So while is nighttime, again, I'm going to say keep sleeping. Okay. And then when we break this loop, okay, we can go out to say wake up. Or yeah, wake up and that's your day. Yeah, very simple. Yeah. And we're getting a couple of interpreter errors already because we haven't defined any code logic under the while loop. So Python is going to have a problem detecting what is actually part of that loop. So you can just add a pass. Okay, a pass is just a placeholder value. It just means the interpreter should ignore that code block for now. It just take it as a valid indentation, because just whenever you have an indent basically and you do not have the logic you'd like to put there yet, you can just make it of a pass. Okay, and the interpreter is going to just keep on. Yeah. So we're going to basically implement a system that detects when it's a new day. Obviously, this program is very naive, so it's obviously not going to be able to check sunlight or whatever. So we're just going to make it that there's a variable, okay, hour of the day, which should be 0 initially, and we want to make it that when it's 10, okay, so when the hour of the day is 10, whatever that means, it should wake up. It should wake up, right? What does that mean? So we're basically going to keep adding to hour of the day. Hour of the day is equal to hour of the day plus 1. What does this mean? We are assigning the value of hour of the day to, well, basically adding 1 to the value of hour of the day and then assigning it back to hour of the day. That's going to make a lot of sense when we print that out. So you can print hour of the day. Okay, so I'm also going to print it out before we add to it. Okay, so let's add a string to add a bit of clarity. So yeah, we print accept multiple values, so you can just go ahead and add a sentence before that and say the hour of the day is, okay, and then that will just come after that. Again, no need to add this. Yeah. And so we can now add a, yeah, let's run that for now. Python loops.py. Again, obviously we're in an indefinite loop. Okay, so this loop is going to keep going on and on and on, which is should be a little bit scary, okay, because it can obviously crash the system. Yeah, so I'm going to stop that with Control C. Yeah, so what happened? Okay, we did not define any condition for the loop to be broken. So the loop is just going to keep executing. I can remove that pass now because it's irrelevant. We have a bit of logic there. So what are we going to do to break out of our loop? Okay, we're going to say that if at the top of our loop, we're going to check if hour of the day is equal to 10, print waking up, and print break. Okay, not print break, we break actually. So break is used in while loops to basically stop the loop, okay, to break out of the loop. Okay, so basically when we call break, we're going to break out of this whole while loop and continue the rest of the program. And interesting to note, if we did not add that break loop, this part of the program, which is maybe like print, we've woken up, will never run. Okay, so we have our break and we have our condition set. Again, this makes a ton of sense. So each time we run this loop, which is nighttime, we're going to print the hour of the day is, and then the hour of the day, obviously. I'm going to check whether the hour of the day is equal to our target time for waking up, which is 10 o'clock. Okay, and then we're going to print waking up and break out of the loop. Else, we're going to add an hour to the time. Okay, now we go ahead and run that. Awesome. So we first of all get the hour of the day 0, which is the first hour, first iteration rather of that loop. We do the same for 1, 2, 3, down to 10, and eventually get to 10, and then we wake up basically. And then the rest of the program runs. Okay. So you can go ahead and start dropping questions in the chat box, and I will be taking them as I go along. Yeah. So